Good morning, students. Welcome to the second or the third practical class. Now today we will be focusing on anions. In the previous two classes, we have focused on cation analysis. We have focused on cation analysis. Positively charged ions, cations we know this, positively charged. So we have done NH4 plus, we have done this ammonium. We have also done lead Pb plus 2. These two ions we have done. Confirmatory tests, identification, the proof number, these things we have done. The two cations done. We are now just changing our flow, slightly with diversion, we are moving to anions now. Why? So why anions? Now look, a compound is made up of cation as well as anion. So we will only focus on cation, not anion. So we will just, it's a balancing situation, alright? There are many anions in our syllabus. So today, out of those, as many are there, today we will be doing chloride ion. We will try to identify chloride ion, whether it is present in a solution, or sorry, in a given sample or not. Alright? Whether it is present in the given sample or not, we will identify that. Now, previously we have taken a salt solution. That means salt solution means OS. OS. This time, in this anion analysis, we have to prepare for anion analysis. We will not, chloride means Cl minus. This is chloride, Cl minus symbol. We have to prepare soda extract. For anion analysis, this preparation is compulsory. We have to do it. That's mandatory. Okay? Soda extract you have to prepare. What is soda extract? It is a short form. Soda extract means sodium carbonate extract. In short, we say soda extract. What is this? We will take a beaker. Always remember, whenever you are doing anion analysis, this is your first step. So OS not required for basically anion analysis. OS is not so much compulsory, but this is compulsory. This is compulsory in most of the anion analysis. There are few, one or two where you have, it is with OS you can do it, but sodium carbonate extract is compulsory. Okay? So we will take a beaker. Within this beaker, we will add. Within this beaker, we will add sodium carbonate, Na2CO3, but anhydrous, not anhydrous. We know that sodium carbonate sometimes it contains water of crystallization is now having 10. If you remember, 10 water of crystallization, Na2CO3 dot 10H2. 10H2, Na2CO3. Right? Washing soda, Na2CO3, 10H2. So, but over here, anhydrous sodium carbonate we will take. To this, we will add the given salt or sample. And finally, plus distilled water for sure. Distilled water. So, we will take a beaker. To this beaker, we will add anhydrous sodium carbonate. To that, the given salt or sample, and then distilled water. Any amount? No, not any amount. 3 parts. That means 3 parts we normally consider as 3 spoons. That means spatula. Okay? 3 parts means 3 spatula. It's a measurement thing. 3 parts of sodium carbonate, 1 part of the given salt, and distilled water can consider 50 to 60 ml. That's enough. This much is enough. More than that's not required. Unnecessary wastage of water. So 3 parts of sodium carbonate, 1 part of the given salt or sample. That means 3:1 ratio. If you are taking sodium carbonate 3 parts, 1 part of the given salt of the sample. Either you will say 1:3, 3 parts has to be sodium carbonate. Alright? And finally, distilled water. This entire mixture, we will stir. Entire mixture we will add and we will stir it. We will stir it, and then heat. That means heat. Once it is heated, we will just boil it for 1 minute to 2 minutes. Then started boiling, we will stop heating then. Okay, we will stop heating. We will cool it. And then we will filter. Once again, filter is there. We will heat from there. After boiling, cool, heat. From there, cool the mixture. After cooling, filter. Now, if you remember, when we were doing that cation analysis, we filtered that one, but we used the residue. Over here, we will not use the residue. We will use the filtrate. So don't throw away the filtrate, please. You should not. You shouldn't throw away the filtrate because you need that filtrate only for analyzing or determining the anions which we're expecting that the salt should have. Like we are focusing on chloride test, whatever. The filtrate will have that anion. So we don't throw it. We need that. Okay? This filtrate now, what we will do with this filtrate? This filtrate now, we will neutralize. This filtrate now we will neutralize. With which acid? We will neutralize with what? With an acid. Neutralize with an acid. Since we are focusing on, we want to analyze, we want to determine chloride presence, whether chloride ion is present or not. So we will avoid HCl. We will not use this. We will not use HCl. The safest stuff we will use dilute HNO3. So we will use a few drops of dilute HNO3 to neutralize this filtrate. After neutralization, we will add silver nitrate solution. We'll add silver nitrate solution. If mind it, if the observation is white PPT, white precipitate forms, then we can say confirmly Cl minus confirmed. Alright, Cl minus confirmed. So let's begin. This is the theoretical explanation. We will begin. So we have taken a clean beaker. You can see this, a clean, fresh beaker. To this, once again, you can see anhydrous sodium carbonate. Anhydrous written. We will use a clean spatula. And 3 parts. 1 spatula, 2 and 3. 3 parts of sodium carbonate. So we have taken 3 parts of sodium carbonate. To this we will add a chloride salt. I'm not showing you the name right now, but I am expecting that this salt is having chloride. This is a chloride salt. Okay? I'm giving you a chloride salt and we will verify this one. Alright, so one spatula given. What is our next step? So our next step is now, so first part over, 3 parts. Second part we have given this 2 over, and a third left, distilled water. I have written 50 to 60 ml, but if you by mistake if you add more, don't worry about that. Nothing will happen. So over here you can see graduations, markings over there. You can see graduations 20, 40, 60, 80. So I will take up till, as I said, 50 ml. So I'll take 50 ml only, or a little less than that. 40, 50. Enough. 50. After this, as instructor or as I written mentioned, that I will stir this. Okay? I will stir this. Okay? After stirring, a little bit of stirring, and then I will place this in on the burner is over here, so I'll place this over here. Let get the solution gets boiled. The moment it will start boiling, bubbles will appear, will start boiling one, we will just remove them. Remove this mixture, the beaker, from the flame. So by the time this solution is getting heated, let me just explain over here that what is exactly happening. When you're adding sodium carbonate to particular all this salt, we are actually transforming, we're actually converting all this sample, this chloride salt. We have taken a chloride salt. Okay? To this, we are actually converting all the chloride salts, whatever, into respective carbonates, and the chloride is coming. Chloride is going into the filtrate or the liquid portion. Into the liquid. For this reason only, we are not throwing away the filtrate, because the anions are getting transferred into the liquid part. Now, once we have taken this filtrate, neutralized with acid, now we are adding silver nitrate. This white PPT, if chloride is present, this white PPT is none other than silver chloride, AgCl. This white PPT is none other than AgCl. This formation of this observation is white PPT. This is your observation, white PPT. AgCl formation is not your observation. Formation of a white precipitate after we add 8 silver nitrate, this is your observation. Okay? Inference of the conclusion is chloride ion confirmed. Okay? So we can now focus on this mixture. It has started boiling. And you can see it's almost a clear solution is formed, no problem. That indicates almost, it's an indication that all the chlorides has been transferred to the respective filtrators. So all right, we will now, we can stir this one a little bit. And we'll remove. It's over. Remove. Okay. Now it's time that we need to cool the solution. Alright? We will cool this. So for cooling, you can do 2 processes. Either you can use a water bath, which is like this pot, metallic pot. You can use a water bath like this, or you can straight away hold the beaker. Under the tap. Your choice. So what I'm doing is right now, I'll just put this beaker inside the water bath so that it gets cool early, faster. You can, if you stir it, it is basically allowing the heat to liberate out. The cold water is outside. We're stirring this. We're allowing the heat more contact, so we're allowing the heat to liberate out at a fast rate. Okay? you can see it's very cool. Temperature is becoming a little more. Now I'm straight away holding this under the water. Under the water, I'm straight away holding this to cool the solution. Lower the temperature to your perseverance level so that you can handle the solution neither too hot and normal room temperature. If you do not take it also, that's not a problem, but yes, it's quite good. It's faster, so pretty cool solution. So now I'll take a little bit of, I'll take this. Now a part of this I need to filter. Now as I said, I need to filter. Interestingly, you can see filtration is required only under such circumstances if you're having a precipitate left inside the boiling mixture. More importantly, this solution is having nothing. No precipitate, nothing. It's a clear, transparent solution. So what I will filter? So that filter portion which is mentioned over here, it is for that part. Suppose if you boil but still you are having some sort of impurity, some solid substance, some precipitate, anything is inside the mixture, you need to filter it out. But in this mixture, in this case, we are having complete transparent solution. So nothing to filter. So we can easily, without filtering also, we can easily take a part of this liquid, because we are interested in the liquid. We'll take a part of this. I've taken this, and now we will add dilute nitric acid. You can see over here, dilute nitric acid. Dilute nitric acid. We will add drop by drop, dropwise. Why? To neutralize. I told you we need to neutralize the solution. We need to neutralize this solution. All right. We have taken a dropper. As I told you. Dropper, and I will add drop by drop. You will see effervescence. You will see effervescence. See? Can you see effervescence? Drop by drop we are adding. So you have to neutralize means no effervescence will happen. Then you will understand, okay, the solution has been completely neutralized. No effervescence will take place. So I'm adding drop. You can see effervescence. This effervescence is due to the presence of carbonates. We have taken sodium carbonate. So the in presence of an acid, carbonates evolve, carbon dioxide gases evolve. So effervescence. So the effervescence should stop. You will add few drops and you will mix it properly, thoroughly, so that all the gas, carbonates, should be neutralized. You can see still effervescence is going on. You can see now, effervescence is going on. I'm adding acid. See, a lot of carbon dioxide is coming out. Carbonates are being neutralized. So now you can see that almost the effervescence has stopped. No more effervescence is coming out. Yeah, with one drop, no more effervescence. So that means this is the indication. No more effervescence with one drop of an dilute acid. Effervescence is not taking place. That means neutralized. To this neutralized solution, I will add silver nitrate. And expecting if chloride is present, I should get white precipitate. Silver nitrate, you can see over here it's written silver nitrate solution. Don't focus on the spelling, it's a slight spelling mistake, it's a typing error. So let me add a little bit of silver nitrate. Oh, wow. You can see the white precipitate over here. Right? From a transparent solution to colorless transparent solution, I've added silver nitrate. You can see white precipitate. Completely white. You can see it over here right now in the light. White precipitate. So this white precipitate, this indicates the presence of chloride ion, as well as this is a confirmatory test of chloride. So chloride ion is confirmed, as I have written over here. Chloride ion confirmed, and with this I have confirmed chloride ion. With your information, the salt which I took was basically none other than sodium chloride. I took a sodium chloride salt, okay, a very commonly available. Okay, so that's all for the first anion test. We'll catch you up with another anion test in the next class. Thank you everyone.